Hey, physics class. I'm going to go over the exercises that I've assigned for this week. It's one, important that you have solutions so that you can check to see that you're learning it. Two, I don't know, maybe I just miss teaching you guys and I want to put something out there for you to have. Anyway, let me get started on that. I'm going to have this calculator up so you can see my steps, and then I'm going to actually enter the numbers. This works out because this is going to be my answer key. So if I go to that email, I can go and find the assignment. So let's start with assignment number 1. All right, so we've got this circuit, and we are doing the go through both or must choose. So resistor 1 and resistor 2, you do not have to go through them both because you could go straight and go around and go the long way. So we do not have to choose. We can go through both. Can go through both. I'm really stupid. I need to start this over. All right, about a minute and a half into it. Here we go. Hey, physics class. I'm going to go over the assignments that I gave you this week. 1, so that you have an answer key. 2, because that's what we would have done in class anyway. You do it at home. You bring it in with questions to go over it. We go over it in class. Also, man, I just miss teaching you guys. So I'm making something so I can give it to you and it can be like we have class again. Anyway, that was sad. Let's go ahead and get started. So I'm going to open up that email that has the links in it, and we've got assignment 1. So if I open that up, we've got the picture of the circuits, and here it's, can you go through both of these resistors or do you have to choose? So it is possible to go through resistor 1 and resistor 2. It's not a problem. So yes, you can go through both. Resistor 1 and 3, yes, you can go through them both if you just go straight. Resistor 1 and 4, again, not a problem because you can take that path. 2 and 3, that's a problem. If you go through 2, you passed 3, you can't go through it. If you go through 3, you went around 2, you can't go through it, so you must choose. 3 and 4, 3 and 4. Turns out that you must go through them both if you go through either, but the point is that you can go through both. You don't have to choose between 3 and 4. Okay, so what is the equivalent resistance of resistor 3 and resistor 4 in series? So resistors in series add up directly. Those two resistors, let me just sketch that, okay? So those two resistors, resistor 3 is 10.7K, and then resistor 4, 870. Since they're in series and they add up directly, it's going to look like this. 10,700, that's 10.7K, plus 870. And we've got 11,570. All right, so let me go over here and enter that in the space. 11,570 kiloohms. There we go. Okay, what is the equivalent resistance of resistor 2 and resistor 3, R4 in parallel? So that's everything but R1. So going back to our picture here, that means that we're taking this picture, but we're including resistor 2. So here's what I'm going to do. I'm going to choose a different color from my mug of markers. Let me go ahead and do blue for this. I'm going to replace resistor 3 and resistor 4 with a single resistor that has that value. And we'll see what the picture looks like now. So we've got, so here's resistor 2 over here. Resistor 2 is 7.6 kiloohms. And then here in blue is this replacement resistor 3 and 4 that has a resistance of 11.57K or 11,570. Do you get the idea? That this pair of resistors has been replaced by this single resistor, which is equivalent to it. Now they are in parallel, which means that we have to add them up like this. 1 over the total resistance equals 1 over 7.6K plus 1 over 11.570K. So that's obviously pretty hard to read in marker, so let me go ahead and do that on the calculator. Let me see, let me clear this. So I've got 1 over parentheses 1 over 7600. That would be that part, plus 1 over 11,570 close parentheses. Okay, so I've got 1 over 7,600 plus 1 over 11,570, and this whole thing is 1 over, because that is well, I'm looking for that resistance, so I need to flip it in order to get there. Alright, I just accidentally closed my email, which is bad. Anyway, let me get back to this. If the answer was that 4,500, there we go. Okay, what is the equivalent resistance of the whole circuit? Okay, so once again, we've got this huge thing that we can replace with a single resistor whose resistance is 4,586 ohms. So that final phase is going to look like this. Okay, I need to remind myself what the circuit looked like. Here we go. Here's resistor 1. Resistor 1 has a resistance of 3.3K. And everything after that can be replaced with this single one that is made of 2 and 3 and 4, and its resistance was 4,586. That's how the circuit breaks down. Okay, well, they're just in series, so we can just add them together. Let's see here. 3,300 plus 4,586, and I get 7,886. Let's select that answer. Here it is. 7,880 is, I just added extra 8s. 7,886. And that'll do it. Okay, well, that was the first one. Since I just accidentally closed the tab with my email in it, I'm going to have to go start this over. So I don't know, maybe I'll make a separate one for... I'll just edit them together.